Hello, good morning students. Once again the part 9, the triangles is continuing in that part 6. Already we have defined components of triangles and also some examples solved on ASA and SAS axioms or congruency properties. Today I am going to continue in that part 6 some other properties of some triangles. Yes? So, some properties of triangles. Particularly isosceles triangle. Isosceles triangle. Yes, can you define when the triangle is said to isosceles? Already so many things, different types of triangles based on angles, based on sides are defined. So in that, some particular properties are there of isosceles triangle. So isosceles triangle is a triangle where ABC is a triangle where AB equal to AC. It means if two sides of a triangle are equal, then the triangle is said to be isosceles triangle. Then what about the angles? That is the property, important property, when by having some activities to construct two or more isosceles triangles, at that time we are concluding that in that triangle, if AB is equal to AC, then angle B is equal to angle C. What are angle B and angle C related to the sides? So that is the property of isosceles triangle. What is that? AB equal to AC. By activity we can prove. So theoretically we also want to prove that by the help of congruence property. So AB is equal to AC, then angle B is equal to angle C. What the relation is there? Angle B is opposite of AC, angle C is opposite of AB. It means that angles opposite to equal sides of a triangle are also equal. If AB equal to AC, then B is equal to angle C. And also converse, if angle B is equal to C, then the sides opposite to equal angles are also equal. These are the two theorems we want to prove today. Okay? Yes, theorem number 1. Angles opposite to equal sides of an isosceles triangle. Isosceles triangle. Angles opposite to equal sides of an isosceles triangle are equal. This is the theorem. So, already we know that once again that I want to remind, theorem contains two parts. One is given, another one is to prove. So, in this theorem statement, angles opposite to equal sides of an isosceles triangle are equal. It means isosceles triangle is given. Isosceles triangle is given. We are going to prove the angles which are opposite to equal sides are equal. So, according to the theorem statement, roughly idea can be shown diagrammatically. Okay. Yes, triangle ABC is a triangle where AB is equal to AC given. Yes, given that in triangle ABC AB equal to AC is given. Yes, then to prove angles opposite to equal sides. Opposite of AC is B, opposite of AB is C. So, we have to prove angle B is equal to angle C. So, when you observe the figure by some particular construction activities, we can tell if AB equal to AC at that time, angle B is equal to angle C by measuring the help of protractor. That is practically. So theoretically you want to prove that at that time we want, according to the triangle chapter, the congruence property is to be applied. So congruence property is applied. So what you want? We want that two triangles. So here only one triangle is given. Two triangles we want to make by some help of construction. So what the construction needs, that we see is construction. Now I am bisecting the angle. I am bisecting the angle A. That is, bisect the vertex angle. Bisect the vertex angle. So AD is the bisector of angle A. So now bisect angle A. So AD bisects angle A to meet BC at B. This is constructed. Bisecting the vertex angle A. That means AD is bisecting angle A to meet BC at B. So at this case we are having two triangles. We are having two triangles. So when bisecting means these two angles are equal. Is it? So that is, bisecting means what? That is, angle BAB is equal to angle CAD. Yes, for this equation number 1. Can help. Yes, so yes, proof. Yes, two triangles are there. Can you name them? What is the triangle? ABB. Another triangle ACD. Try to show them congruent with the help of some congruence relations. That is postulates. Okay. So now in triangle yes, proof. In triangle ABD, in triangle ABD and triangle ACD, triangle ABD and ACD. Yes. So given that AB equal to AC, it is given. Okay. It is given. Angle BAD is equal to angle CAD. We have constructed. So by construction we can write, or by from 1. And AD is common. AD is equal to AD, which is common. So what we can understand by this? Yes. So by help of SS property, triangle ABD is congruent to triangle ACD by SAS congruency. By SAS congruency. Therefore what? Therefore angle B is equal to angle C. Means therefore angle ABD is equal to angle ACD. Reason is corresponding parts of congruent triangle. That means angle B is equal to angle C. So what is the theorem? Angles opposite to what? Equal sides of an triangle, of an isosceles triangle, are equal. See how we are using, that is SAS property, SAS congruence property. Yes, so with the help of SAS property we can do that. So very important point is, in isosceles triangle the angles opposite to equal sides are always equal. Yes, and another important property also we can prove here. See, so in isosceles triangle, just I will tell that you can remember always. Otherwise, in the form of corollaries you can write. Yes. Also, these two triangles are congruent. So BD is equal to CD. Also, BD is equal to CD. Yes, BD is equal to CD. That is CD. And secondly, angle ADB is equal to angle ADC. So also CPC. Yes, but what happens here? But ADB plus ADC is equal to what? Linear. Where 180 degree. ADB plus ADC equal to 180 degree, and they are equal. Therefore, ADB is equal to ABC is equal to 90 degree. Very important property. Yes. So, what is the theorem, or can tell, or some points can tell? The bisector of vertex angle. What it is? The bisector of vertex angle of isosceles triangle is perpendicular to the base and bisecting the base. See, is perpendicular to the base, bisects the base. The very important property. What is that? Once again, it is the bisector of vertex angle. So bisector of vertex angle of an isosceles triangle is always perpendicular to base, bisecting the base. Okay. So if bisecting the base and perpendicular base, then the sides of that triangle are equal. At that time the triangle is isosceles. Okay. So these two points also you have to. So corners of this theorem, what you can tell? If two angles of a triangle are equal, then sides opposite to them are also equal. That is corners. As theorem 2, that is converse of theorem 1, that is sides opposite to equal angles of a triangle only, of a triangle What it is? Sides opposite to equal angles of a triangle are equal. First theorem I proved angles opposite to equal sides of an isosceles triangle are equal. Here sides opposite to equal angles of any triangle are always equal. That you have to prove. So again, what is given here? Sides opposite to equal angles of a triangle. Equal angles are given. We are going to prove sides are equal. So roughly identical. SABC is a triangle and angle B is equal to angle C is given. S given in triangle ABC, angle B is equal to angle C is given. Then what to prove? To prove sides opposite to equal angles. Opposite of angle B is AC, opposite of angle C is AB. So AB is equal to AC. You want to prove. So once again, we know the properties of congruence of triangles. We require two triangles. For that, we want to have construction. Yes. So construction here. What is the construction we are doing? That draw AD perpendicular to BC. Draw AD perpendicular to BC. So draw AD perpendicular to BC to meet BC at D. Yes, construction C now. Okay. So by the help of Connor's theorem only we can tell that, otherwise another property we can use. Okay. So now proof. S in triangles, that is A, B, D and triangle A, C, D. Simple theorems. S angle B is equal to angle C. Angle ADB is equal to ADC equal to 90 degree, and this is common. So AAS or ASC, that already we know very well. AAS, AAS. S angle ABD is equal to angle ACD is given. And angle ADB equal to angle ADC equal to 90 degree. We have constructed. And AD is equal to AD, which is common. AAS. Therefore, triangle ABD is congruent to triangle ACD. By what? By AAS congruency. By AAS congruency, of triangles are congruent. Therefore, AB equal to AC. Therefore, AB equal to AC. Corresponding parts of congruent triangles. Understand? Points. In isosceles triangle, angles opposite to equal sides of an isosceles triangle are equal. In any triangle, if two angles are equal, then the sides opposite to that equal angles are always equal. That is congruence. Yes, in this way we are using SAS property and ASA property you can tell, or AS property you can tell. Understand? So once again, that is here 90 plus 90 180 degree, that is perpendicular, and these two triangles are congruent, so BD equal to CD, and it means very important property of isosceles triangle. The perpendicular bisector of base in isosceles triangle also bisects the vertex angle. This is common. Yes, or bisector of vertex angle of an isosceles triangle is always perpendicular to the base and also bisects the base. So these are the very important terms. Yes, just one example we want to see. Yes. Example number 1. In an isosceles triangle ABC, yes, in triangle ABC, AB equal to AC. The bisector of angle B and C intersect each other at O, join A to O, then show. In triangle AB equal to, in triangle ABC, AB equal to AC. Yes, in triangle ABC, the given AB equal to AC. Yes, the question is, the bisector of B and C intersect each other at O. Bisector means equally divided. Bisector of B and C. B and C intersect each other at O. Join A to O. Join A to O, then to prove then show that OB equal to OC and AO bisects angle A. That means OAB is equal to OC. Yes, very important. OB equal to OC. OB equal to OC. OB equal to OC. So OB and OC comes in the triangles OAB and OCB. OAB and OAC, or OBA and OCA. Yes. 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 In triangle ABC, AB equal to AC given. AB equal to whole triangle ABC. AB equal to AC. Therefore, what? Angles opposite to equal sides of a triangle are equal. Therefore, angle ABC equal to angle ACB. And what is OB? OB is a bisector. Bisect means exactly two parts. It means, therefore, half of angle ABC is equal to half of angle ACB. Is it? Okay? Understand? Therefore, yes, it implies angle OBA is equal to angle OCB, and also OBC is equal to angle OCB for this equation number 1. Yes, in triangle OBC, angle B is equal to angle C. Yes, in triangle OBC, OBC equal to OCB. This is from 1. From 1 we have proved. Therefore, what is that? Corner's theorem tells that sides opposite to equal angles of a triangle are equal. So OBC equal to OCB, it implies OB equal to OC. First one is OB equal to OC is OC. Okay. Important point is OB is a bisector, very important. Whole angle B is equal to whole angle C. OB is a bisector, OC is a bisector. Half of B is equal to half of C. Tells that OBC equal to OCB. So angles are equal. So sides opposite to equal angles are equal. Okay. Here. Yes. And now in triangle, what we are going to prove? OAB bisects. AO bisects in triangle OAB and triangle OAC. Yes, OB equal to OB proved. So OB equal to OC proved. Angle OBA is equal to angle OCA. This also proved. And AB equal to AC given. Yes, yes, A, yes, yes, A, yes. Therefore, triangle OAB is congruent to triangle OAC. By what? By SAS congruency. SAS congruency. Yes, congruency. Yes, therefore what? Therefore, angle OAB is equal to angle OAC. What is the reason? Corresponding parts of congruent triangles. OAB equal to OAC. By OAB equal to OCB, not OAC. OAB equal to AO biceps angle OAC. OAB equal to OAC implies AO biceps angle A. I was using that first property, bisector angles opposite equal sides of triangle are equal, bisector, then sides opposite equal angles of a triangle are equal. Then by help of SS property we are proving OAB is congruent to OAC. It tells that this part is equal to this part, means AO is bisecting angle A. Yes, some more examples we will see in our next class. Okay, thank you.